4th of next month is when your classes will stop, and you need to start writing your midterm one, right?
Yes, sir.
As I understand. Okay. So for how many days is this for? 5 days or 4 days or how many days? It starts from
6 days,
4th
sir.
up to 6 days.
9. Yes, sir.
Huh?
Sir,
4 to
6 days, 4 to 9.
Okay, okay. So when is your date sheet for your examination likely to get out? I mean, likely to be finalized.
So probably in a day or two.
Okay, so probably by next class, by the weekend. Okay, as far as the assignments, I think this weekend, and or maybe the next week, I'm also going to be posting questions and assignments that are related, and you are expected to do them, and that would help you to get better understanding of the assembly language that you are putting across in your 8085 microprocessor. So I think this is what we were doing last time. If you remember, this is what you were doing last time. And I did ask you to calculate. So anybody who faced any kind of problem have anybody who has question regarding this? Remember, we are talking about two things now. One is basically that each of these, we've already talked about different types of instruction set. Now, each instruction set that you can see here, this is actually designated by an equivalent binary form. So what your machine understand is the binary of, say, LXI-B. That is basically that you're giving the value to your B and C registers on an immediate basis. And here the value happens to be 1000 in the hexadecimal form. So this will also have its equivalent binary form, which the machine would understand. Is that clear? This is very important. And while doing all these things, it will introduce what you call as the delay. Okay, so this operation per se, like this particular operation per se, requires 10 T states. Similarly for the next instruction, which is like DCXB. So can you see, I think somebody was having the ebook. I just saw there were 26 or 27 again. Is there some network problem? Anyways, doesn't matter. Somebody was having the ebook.
So I have the ebook.
So I think I did ask you to kind of share it with all the rest of the other students. Did you do that?
Uh, so you asked to share the hex number table, so I shared with the group.
Okay, so can I know the equivalence of, say, this, say, DCXB?
So when
It's equivalent binary or hexa? So this would not have any hexa. This is your
so DCX is
opcode. So this is the opcode. What is its equivalent binary? Everybody.
So hex code is 0B.
0B.
Yes,
Huh?
sir.
It's equivalent binary form. This should be an equivalent 8-bit binary form, which the machine understands, which your microprocessor understands. What is that? Similarly, for the instruction move A, comma C. All of you, please check. Sandeep, Dhirendra, Rajiv, Sandeep, are you there?
Yes, sir.
What is the equivalence binary form say for opcode move A, comma C? Dhirendra, for say ORA B. Yes, Rajiv, Rajiv, are you there? Rajiv Kumar, Kunal Kaushik. Okay, mic is not working. Okay, Kunal Kaushik, are you there?
Yes, sir.
Okay, so can you tell us the equivalence binary form of move A, comma C?
Sir, it's 79 in hexadecimal. 79 in hexadecimal.
I'm talking about binary form, so please stick to what I'm asking. You don't have to answer me anything. Take your time and then answer. Yes? Kunal?
Sir, 4 times 1, 001.
That's 7 bit. Can you repeat?
Sir,
4?
sir, 4 times 1, 001. And you can put 0 at the most significant bit.
So tell me again, I mean, like, I still don't understand. You need to tell us the 8-bit equivalence.
Yes, sir. 0,
Tell me the 8-bit equivalence.
0, 4 times 1, 001.
So, Rajiv, is that correct? Is that correct, Dhirendra? The moment you say yes, I can at least go to the next slide. Anybody?
Yes, sir, it is right.
Sandeep?
Yes, sir.
Is he correct?
Yes, sir.
Okay, so now we go further. We just talked about a single loop. Instead, we will be now progressing to a nested loop, which is loop within a loop. So there can be There can be challenges or problems that would require you to form the assembly language programs as a in a nested loop form. So here you can see, you can note down, this is the representation. Please note down this. So you initialize, say, a loop 2, which is the outer loop, then you talk in terms of the body of the loop, then you initialize the loop 1, then the body of the loop 1, and then there is a update of the count, which can be either incremental or a decremental. If the final count is satisfied, then it goes further and updates the second count. Else it goes back to the loop, the inner loop, or loop 1. If it's satisfied, it updates count 2, and then again, if it is satisfied, it comes out, else it goes back to your loop 2. So this is the basic philosophy behind a nested loop. So this is generally done by using two or registers for a 2-loop counter, and you can have multiple loops. So here is an example. Please note down. Now, all of you try to calculate the delay which is introduced using this. So here you are having loop 1, loop 2. So the outer one is loop 2, inner one is loop 1. So can you determine the overall delay? Class? Let's begin with whosoever are there. Arvind?
Yes, sir.
Yeah. So what does this statement mean?
Sir, move immediate data 10H, like 10H into the register B.
Okay. Next. Who is next? Dhirendra. What does the next statement represent? I think he's online, but he's not talking, or something is wrong. Sandeep? Sandeep?
Yes, sir.
Yeah, what does the second statement stands for? What is this?
Move immediate data FFH in accumulator C. Move immediate data FFH in accumulator C.
What is H? What is H?
Hexadecimal, sir.
So what is the data?
FF.
FF. And so you are now uploading your register C with data FF. Okay. What
Yes,
is
sir.
Rajiv? What does this mean? Anmol? Rajiv gone. Rajiv?
Hello? Yes, sir.
What does this statement stand for? Anmol, what does this statement stand for? Can you see this or
Just
not?
joined my network lost.
Rajiv, can you make it fast? What does this statement stand for? What does this statement stand? Chamanpreet?
So decrementing the data by 1 register C.
Okay, next. Aditya.
Yes, sir.
Aditya,
Yes, sir.
now what does this statement stand for?
Sir, until loop 1 gets 0, the JNZ get run. I mean, decrement by 1. C gets decremented by 1.
No, only this statement. How can it represent so many things? What does J and Z stands for?
Until the zero flag will be set, the loop get run.
Okay. Navratan. What does this statement stand for? He's not there. Navratan? Premlata? Premlata, you there? I don't know. Manali?
Yes, sir.
Yeah. What does this stand for?
Sir, decremental in register D by 1.
Okay, last. Samata?
Yes, sir.
What does this stand for?
Jump on not 0, sir. That indicates.
So now you calculate the delay. All of you. Navratan, where are you? Okay, mic is not working. Rajiv, you're not able to understand? You've written, I don't know. Rajiv? Can you answer me? What you don't know? Kunal? Kunal Kaushik, have you been able to determine the overall delay? Considering this is 8085 microprocessor and say its frequency is Kunal?
Yes, sir.
Have you been able to determine the delay?
So in previous class, actually I didn't understand the delay.
You were there in the last class?
So my net is not working at that time. So previous class, 15 or 30 minutes I did not attend that.
Okay. So what you're not able to understand from this?
Sir, how to calculate delay by T-state? Sorry.
Now I don't have, I mean, probably that would require, so this is the delay. Total delay is the delay that is created due to the outer loop and due to the delay of the loop. So loop can be singular, can be dual, or can be multiple. That is what we had just talked about, which is a nested loop. And depending upon the value that you are giving, assigning, you can actually find out the total number of T states. And that is directly related to your determination of delay, because you already know the frequency of operation of your microprocessor, which is 8085 microprocessor. The range is around 2 to 3 megahertz. So that's how you will be determining the delay. Anmol? Aman? Anmol? Am I audible or not?
Yes, sir.
So were you able to figure out how many T states?
No, sir. I'm trying looking for notes.
Huh?
No, sir.
Sir,
Anil? Anil? Anil?
Sir, yes, sir. Sir, I'm losing the network, so that's why I'm repeatedly rejoining.
Okay, so try to find out the delay. I'm just giving you a few minutes because this is very important. Unless you understand this, then I will start giving you programming languages. So here we already introduced the concept of nested loop. Just for example, if you want to do, say, multiplication by repetitive addition, you may use, this is a very simple and very, very simple example. So you should understand this. Then you can also determine it's delayed. You should be knowing all these things. It's very critical. Yes, any volunteers?
So 57,412.
57,000. Okay.
412. These states.
So let us see. So the outer loop is having 70 states. Is that fine? Which is your outer loop? This is your outer loop. Yes or no? Class? Somebody
Yes, sir.
say yes or no.
Yes, sir.
Aditya. Aditya, you there? Aditya Sai Kamal.
Yes, sir.
Huh. What are the three loops? This is the outer loop, and what are the other loops?
The next three.
Next three? Are there three more loops? How many loops are there? There are only two loops within this. One is this
Next three instructions.
loop. This is the first nested loop, and this is the second nested loop. Loop 1 ends here. Loop 2 ends here. So to calculate this, first we are talking about the outer loop and then the inner loop. So how do you calculate the inner loop? Sai, Aditya, are you there?
Yes, sir. Yes, sir.
हाँ तो बताओ, just tell me what is the value that you are assigning to your register C? It is FF.
5.
So then it will go to this one.
Your voice is breaking.
My voice is breaking.
Yes, sir.
Anmol, Anmol, Anmol is left. Anil, Anil,
Hello?
yeah, can you tell us how did we calculate this? Are you able to understand or not? So how did we get this 3, 5, 6, 70 states? It is having a value of 255 into 14. Why is it 14? 10 plus 4. So this loop, the inner loop, not the inner loop, but loop 1, 14, because the value is FF. So that's why we are talking about 255. And the last one would not be having 10. So it is 7. So actually it is 3, 5, 6, 7. So this is the T states for loop 1. Anil? Is that clear? Anil?
Yes. Hello.
Yes, sir. Okay.
Hello.
Yeah. Then we talk about the loop 2. That is 16 into 14 plus 3574. So why is it 16? Anybody?
So what 10 का वो 16 आ रहा है सर.
Hanji, I didn't catch you.
So 10h equals to 16 in decimal. So that's why it's like 16 times. It's 16 times it will repeat to get to 0.
Correct. And then
so
14,
that's why it's 16.
10 plus 4.
Yes, so 14 for decrement and jumping to the specified for decrement of V and jumping.
Just a moment. So 10 is coming from the value which is here.
From jumping loop to, yes sir, from loop 2 to loop 1.
Then
it's a 10 for jumping and 4 for decreasing the value, decrement of value by 1, like 16 to 15, 15 to 14.
Correct.
So
okay.
That's why it's 14. Yes sir.
Plus your loop.
So how much times the nested loop? So nested loop, how much times it has gone? Like 3, 5, 6, 7. This value plus 14 times for the outer loop.
Okay, and that would be multiplied by 16. How did you get 16?
Sir, like in 10h equals to 16 in decimal, so 16 to 0. We have to run by 16 times.
16 times.
Yes sir.
Except for the last loop. So it would be
yes sir, except for the last loop. Yes sir.
So this is the total T states. Would be sum total of everything. So now if I change this value to, let's make this, instead of this, let's make this 1F and let's make this AA. Calculate. Have you got the question? You're talking of the same nested loop. Instead of this value, we give a value 1A, and instead of this value, we give a value AA. Am I audible?
Yes, sir.
Please calculate it fast. Tell us the T states. I see a lot of people leaving and coming. Is there a lot of network issue? And sometimes it happens, the moment I ask you a question, you have left the room. It's some of the students. The moment I ask you a question, yes, any volunteers?
So 74,342 T states.
I have not calculated. So, how many? Who was this?
Sir Manas.
Okay, so how many of you are satisfied with Manas' answer?
Sir, I got 62,345.
So you're not satisfied. So please check your this thing again.
What was the value instead of 10h? Sir, what was the value instead of 10h?
What is that you have written?
Sir, I only
1F.
got a 1f. I only got 1a.
1A.
Sir, you said 1F and AA.
1F and AA. Okay.
And for this, I got 74,342.
So the value
Sir,
is
that
1.
might be correct.
Huh?
Initially, you told 1F and A. After that, you changed it to 1A and A. So I calculated for 1A.
Oh. Maybe. So make it 1F and A.
Okay, sir.
So those who have done, they can also try to perform multiplication by repetitive addition. And you can use this concept of programming for the same. So suppose you want to multiply a digital number, say 5 cross 20 or any number. How would you do it? You can use the concept of the nested loop. Yes or no?
Sir, I got 76,495 T states.
I think you need to let me know what is the value that you took for storing in register B and C. Then only one can cross verify the results. And I have not calculated here, or I do not have.
Sir, 1f means 31 from storing in B. And
1F.
A means, yes, sir.
Okay, so you have taken 1F and A, right?
Yes, sir.
Okay, just ask the class if they are getting any other answer.
Answer for A, it's 170.
So as I understand, everybody should be getting the same answer, isn't it? May I know who is online? Whom I am
Sir,
talking
it's
to?
74392 for 1F and AA.
So 74118, I think.
74335, I guess.
So there you're missing something. Everybody is having a different answer for the same question. That is either one is right or all are wrong.
Sir, I'm getting 74,342 T states.
Sir, I also got the same. 74,342.
74,000.
For 1F and AA, right?
74,342.
Yes.
Okay. So that means you have got the basic concept. I think there are some network issues. I see 25, 24, 23, 21 right now. Again, it goes to 23, 25. I really do not know what's the issue. So you should make sure that when you're taking the class, your network issue has been resolved. Otherwise, if the continuity is broken, then it will be difficult. And now we are getting into more and more sophisticated things. So this is what we talked about, the total delay. Now, there are other ways in which we can also introduce the delay by using some kind of a register pair for each loop counters in a nested loop, and also by adding some dummy instructions like NOP, which we have talked last time. Now, following this, we also talk about some timing diagrams. So please note down. Remember, your program is when you're doing a assembly language program for your microprocessor, there are three major functions that you're doing. One is the fetching of data. The second is decoding. And the third part is execution. Fetching, decoding, and executing. And you can see very well that as you are giving the instructions, say like move A comma B, so its corresponding code is 78. What does move A comma B do? What does A comma B do?
Moves data from B to A.
So remember, we talked about first identification of the address, and address in your 8085 is of 16-bit, while the data is only of 8 bits. Communication at any single time is also of 8-bit in your 8085 microprocessor. So Even previously we have talked about using the concepts of ALE and sustaining of your lower order and higher order address for 1 T state and 3 T states. So when you are performing your read and write operations, along with the enabling of your latches, it would be following this kind of a matrix, time matrix. So you can please note down this. Moment you're talking about, say, what does 78 mean, class?
Sir, instruction code for move AB.
Can you check its equivalent binary form? Those who are having the appendix of your book by Gaonkar.
Yes, sir. Yes, sir, it is 78 only. Hex number of move AB is 78.
So that's a hex number. Remember, that's a hex number.
Yes,
What's
sir.
the equivalent 8-bit binary?
Sir, 0, 1, 4 ones and 3 0.
Correct. Okay. So you would want, since you already know that when you're talking about your addresses, its lifetime is up to 3 time cycle. We have already talked about 1 time cycle and T time cycle. And your address is bifurcated into the lower order and the higher order. Right? So similarly, what all gets activated in your read, write and input output statements while you are fetching, decoding and executing your instructions. So here we are just only talking about the fetch cycle in terms of its timing diagram. So your ALE would be in the highest state for the very first part of the timing cycle. Similarly, for read and write statement, please note down this.
Sir,
Yes.
say one doubt. When we are saying move from register B to register A, are we deleting the data which was in register B, or
No.
the data remains
That
there?
basically simply means whatever is stored in B is simply overriding it into your accumulator, which is A.
Okay, sir.
So that is happening within your CPU system. Let's take another example. You have instruction in which you want to have a value of 45 into your accumulator. You want to immediately move the value 45 into your accumulator. So its corresponding hexadecimal codes are for 3. 3 is for your MBIA, move immediate A. And 45 is the value that you need to assign to your accumulator. So this is how your various read, write, input, output, memory, and your ALE system will be getting into activation. So up to T4, you have the opcode fetch cycle. Then from T5 to T7, you will have the memory read cycle.
So can you repeat again because your network problem?
Yeah, can you be louder? I cannot hear you. What is that you're asking?
Sir, I missed something because of network issue. Can you repeat again?
Even I am not able to understand what you're saying. Hello? Can you be louder and more clear?
So can you repeat again?
Yeah. So first of all, you draw this. So basically, we are again talking about this instruction. It can be bifurcated into the opcode fetch cycle, which is up to T4. So this is basically the timing diagram. So essentially, it is talking about how does internally the whole timing things happen. So up to T4 cycle, you are having both your lower and higher order of the address bus be fetched or being concentrated upon. So that would have a, a timeline of up to T3 stage. And the overall opcode, which may require both your read and writing as well as all type of input output, that would be completed in a T4 cycles. So this T4 from 0 to T4 cycle is for the operational code fetching, which is when you're talking about MBIA. So it will have the data or your lower order addresses in T1 cycle, while it can sustain up to T3 cycle for your higher order address, and for the complete opcode to be fetched, its lifetime would be up to T4. Then for the memory read cycle, it will extend from T5 to T7. So 3 T cycles or 3 T states. The correct word is 3T states. So like here is another example in which is loading into the accumulator the value F045. Loading immediately into the accumulator value F045. So here you can see the opcode fetch cycle extends up to T4 states. Then your memory reads cycle is bifurcated into 2 because you are talking about 16 bits. So it extends from T5 to T7 and T8 to T10. Manali,
Yes, sir.
are you getting?
Yes, sir.
Now if you please note down this one, the last, sorry, not this one.
Hello, sir. I have some little bit doubt.
हाँ, go ahead.
सर ये जो आरडी लिखा है जिसमें रीड कर रहे हैं मेमोरी से, तो सर आरडी बार क्यों लिखा है?
कहाँ आरडी लिखा है?
कैपिटल आरडी बार.
Read. So basically it is just following from. So if you go and see the previous internal diagram, you would see that the values are coming as a complement of the processing signal. RD bar, write bar, and input output from the memory bar. So if you actually see, they are sending the signal from the complementary part of the data. Now, I think this is the next thing which we would like to study, which is stacks and subroutines. Again, this is very important. But before this, I would ask you to right away I would want all of you to write a program which is for multiplication of two numbers by repetitive addition. So suppose you have a number stored in memory location, say 2000. And the other memory address is 2002. So you have two datas. One is stored in memory location 2000. The other is memory location 2002. Now you want to perform multiplication of these two numbers using the concept of repetitive addition and the concept of nested loop. After you have performed the complete, after you have completed the operation, you need to store the result in, say, 2050, 2050. Can you write an assembly language program? Kunal, can you repeat the question? I wish I was having a blackboard and things would have been far much. Can you repeat the question? Okay, so please do that. Anand, are you there? Well, again, I see 17 students are there. So what's?
Yes, sir.
Yeah. So can you repeat the question?
So multiplication of two numbers by repetitive addition.
Huh. So where are the two numbers stored? That's also very important. You're not just giving two number arbitrary.
One in 2000 and other in 2002.
Huh. The memory location is.
The first one will be stored in 2000 and the second one will be in 2002, sir.
Yeah.
And the result will be in 2050.
Okay. So please do that. All of you.
Yes.
And you can use the concept of your nested loop. Yes or no? Yes.
Yes, sir.
Yes, sir.
So we shall be talking about stats and subroutines in our next class, where you can actually call a part of your program while executing a sequential set of instructions. Are you there? So somebody was already having the appendix. Can you share with the class here?
Sir, I already shared it with the class.
No, here,
So it's in the group.
Here on this, I mean, like just now. On.
Okay, sir.
I mean, like here as in like Google Meet.
Yes, sir, I can share.
Yeah, you can share so that people
Okay,
can,
sir.
if they need any kind of. I see almost, I can see only 17 students now. What has happened? I mean, like some internet problem, or they were around 26. I can't see Sanya. I can't see.
Sir, is it visible now?
No, nothing is visible.
I can see.
Sir, I also.
What you can do is you can send it to email, so I can send it. I can display it on the screen.
Okay, sir. So can you share your email ID with us?
Mhm. So rest of you, kindly let us know what is the. I mean, are you finding any difficulty before I proceed further? Are you there? I'm not able to. Am I audible?
Yes, sir.
What has happened in the class? I think from 25 to 16. Is there some network issue or? I'm not getting any response whatsoever. Do I need to log in again?
No, sir, we are trying to do the.
Okay. So this is very important. I think, can you see the screen? This is very important. Those who have not copied this, please copy this. This is to understand about, say, when we are talking about the different instruction taking different T states, it is in accordance to this. The opcode actually takes a 4 plus 7, 3 plus 3, which is around 10 T states. And that is how we have talked about. So like this instruction, like LXI F045H. So basically what does this mean is that you are transferring the value on an immediate basis to your accumulator, and that is having a higher order and a lower order bifurcated. This is like F045. So 45 and FO, depending upon whatever the number is, you will have bifurcated into lower order and higher order. And so this will actually take 10 T states, which is what you can see. So from 0 to 4, it is actually talking about the fetching of your opcode, and then it is talking in terms of memory read cycle for the lower and higher order. And then we are talking about the how does your latch enabler works. So latch enabler works is like that after every fourth cycle, it will be in the active state. And similarly for your read and write statement. So generally when we are talking about read, we are getting the inputs from the complementary part. So that because and so this read and write statement behaves in this manner, and for the input and output of from your memory, it is behaving in this. So this is helping you to understand why different types of instructions take different T states when we are talking about all these things. So like for this instruction, for this instruction, for this instruction, so on. So like when you're doing a decrement of C, it will only take say 4 T states. So this is what we are trying to explain further through this timing diagram. Class, are you there?
यस सर सर ये ऊपर जो हायर ऑर्डर एड्रेस बस लिखा है इसमें मतलब ब्लू रीजन स्लाइड में यहाँ पर
हाँ
सर इसका मतलब है कि हायर ऑर्डर एड्रेस मतलब अराउंड 10 टी स्टेट्स के लिए यूज हो रहा है, मतलब हमेशा यूज हो रहा है हायर ऑर्डर एड्रेस?
नहीं, your address is a 16 bit. So address is bifurcated into A0 to A7, which is lower order, and A15 to A8 to 815 higher order. So we have talked about this before when we were talking about multiplexing and the concept of ALE. If you remember.
Sir. Yes. Yes.
Do you remember or not? We had done this long time back.
Yes, I remember that. I'm just asking that this higher order address is being used for the whole 10 states during the whole operation.
No. It's only for. It is only up to 3 states plus 1, which is 4 states. So here we had talked about, we had talked about bifurcation into the lower order of your address and the higher order of your address. So we are using the same buses, but with the usage of latch, we were able to sustain it for 3 time cycles. Remember this?
Okay, sir. Yes, sir. Yes, sir. Yes, sir.
The lower order is only remains for 1 clock cycle, clock period, 1 clock cycle or 1 clock period, while the higher order was for full 3 clock cycle. Do you remember this?
Okay, sir. Yeah, I understood now, sir.
So overall, when you are talking about, it is actually talking about. So what we are trying to explain you further in this class is, suppose for this instruction, why is it 70 states? Or suppose for this instruction, why is it 70 states? Of why for this instruction it is 40 states. So taking an example, we will try to make you understand on these lines. Like here it is only talking about 70 states, out of which the first T states is basically corresponding to your either the data, this from 0 to T4, it is talking in terms of the first T1 would be for your data or your lower order address bus, while from T0 to T3, it will be talking about the higher T state. So here, if you see the corresponding value for your MVI A would be coming in this. And why so? Because your overall value can be sustained up to 3 T states.
Okay, sir. Yes, sir. Overall value can be sustained for 3 T states. Yes, understood. Thank you, sir.
So how many of you have finished with writing the assembly language program using this nested loop? So where are the students? I mean, like there were 25, 26 students. Did they find some permanent network issue? I mean, like I did see them for most of my class up to. And I see a lot of you logging in and logging out. I mean, like, is it that today there is more difficulty or something else has come up? Yeah, so Samatha, you finished? Samata,
Sir, yes, sir.
Sandeep,
No, sir.
Manas.
Sir, I have finished, sir, but it's requiring only one loop the way I have done. I want to show you, sir. I can show you also.
Yeah, had I been in the class, you could have shown me.
Sir, I could finish. I can
also
finish.
Manali. So
Yes,
I
sir.
think now the only possible way of showing is like I will give you the assignments and then you can send it to me on this Google Classroom.
Sir,
So
I can
that
screen share now.
yeah, somebody did screen shared, but I couldn't see myself. I mean, like I think one of you, I asked you so that everybody can see that appendix of the book, but I myself could not see it. I really do not know how many of you were able to see that. Yeah, Manali, Kunal, any questions?
No, sir.
If not, I think I will be putting up the assignments now, which would be extended version of what we have done till now. And next class, I will be talking about subroutines along with whatever instructions that we have not covered till now. So we will be going with much more sophisticated instructions, and so that you are able to write different types of programs and get acquainted. So I will be sending you the assignment now. Any questions? No questions?
No, sir.
Then thank you. And then I mean, like if you're finding any particular difficulty in the network, please resolve next time, because I did see around 25, 26 for most of my class. And I don't know, suddenly what has happened. They are having some network issue. And whatever I talk in the class is important both for your learning as well as for your examination, particularly for your examination. And don't expect me at the fag end. You will ask me at the very end. You will ask me, okay, I want to if I can upload the slides. Which the very reason I don't want to promote that is for you to be resolved. I mean, like resolute in your conditioning, so that you're. I mean, like you attain